Similar to our other factoring problems, we have a combination of positive and negative numbers. In this case, in our second term, 7 will be positive, which represents B. In our third term, our C value is negative, as negative 18. With our organizer, we know that we want to put 7 on the bottom to figure out what two numbers add to 7. And we're going to put negative 18 on top to figure out those same two numbers that add to 7 have to multiply to negative 18. First, I'm going to write down a list of all the numbers that multiply to negative 18. Well, we know 1 and 18 multiply to positive 18, so we have to make one of them negative. And we want to do the opposite, 1 and a negative 18. We can also think of 2 and 9, where the 2 will be negative and the 9 will be positive. Then we can switch it so the 2 is positive and the 9 is negative. We can also come up with 3 and 6, where 3 is negative at first, and then we can switch it for 3 and 6 so that 6 is negative. Now, when we add the factors together, you want to figure out which one gives you a combination of a positive 7. Now, my first two examples don't work. When I go ahead and I add my third example, I end up getting that positive 7. I can go ahead and stop right there, knowing that there's going to be no other combination where both factors multiply to negative 18 as well as add to positive 7. I can go ahead and put negative 2 and a positive 9 into my organizer, and that'll help me figure out how I can write my initial trinomial into two binomials. Remember, this is just another way to represent the given trinomial. Remember, our two initial terms have to multiply to x squared. So we know we're going to fill in x into the beginning of each binomial, and then we can go ahead and fill in our two factors of negative 2 and a positive 9. Let's go ahead now and multiply our two binomials just to double check that we get our original trinomial. I'm going to try distributive again this time. If you want to try foiling, that should work just as well. I'm going to take my initial binomial and give each piece to the second binomial. So I'm going to multiply x times x plus 9. And then I'm going to multiply negative 2 times x plus 9. If you go ahead and distribute x times x, you get x squared. Multiply 9 times x to get 9x. Then distribute that negative 2 to each piece to get minus 2x minus 18. If we go ahead and combine our x values, we end up getting x squared plus 7x minus 18, which, if we double check, it matches our original trinomial. So we know that our found binomials of x minus 2 and x plus 9 work.